In finding the scale factor of the enlargement, because what we have right here, this triangle and its image after an enlargement, we need first to find the scale factor of the enlargement, and that may be done by take the length of one side of the image and divide it by the length of one side of the original. One is given right here. So m prime n prime divided by mn, that is 16 divided by 8, and the scale factor is equal to 2. Although we already know that OM is equal to 10 centimeters, OMN is a right angle triangle in which the longest side is missing, which is of course OM. Pythagoras theorem may be used to find OM. OM is the hypotenuse. We have two short sides. Use Pythagoras. 6 squared plus 8 squared. The square root of all of that. When we square 6, we get 36. When we square 8, we get 64. Add those, we get 100. The square root of 100 is positive or negative 10, but we are talking about the side of a triangle cannot have a negative value, so OM is 10 centimeters. The relationship between an object and its image in an enlargement is such that the length of any side of the image is equal to the length of the corresponding side of the object multiplied by the scale factor. We need to find OM prime. In order to find OM prime, we take the length of the side of the triangle, the original, and multiply that by the scale factor, and we will have the length of OM prime. So OM prime is equal to the length of the original corresponding side multiplied by the scale factor. The scale factor is 2 and OM is 10. OM prime is therefore equal to 2 times 10, 20 centimeters. Multiple choice solutions contain extensive explanation on right angled triangles that may be consulted in order that we might understand how it is possible to look at the problem and know that OM is 10 centimeters. QS is opposite to 15 degrees. And of course, the triangle PQS is right angled. So QS in this right angled triangle is opposite to the angle that is 15 degrees. That is PQS. QS is opposite to the 15 degrees angle in the triangle PQS. So this is QS and it is opposite to the 15 degrees angle. The other side, 12.6 meters, is the known side. And that side is the hypotenuse. So QS is the opposite. We have the hypotenuse. The trig ratio that pertains to opposite and hypotenuse is the sine trig ratio. So opposite over hypotenuse is equal to sine of 15. So QS over 12 is equal to sine 15. And there we have the opposite to this angle is QS. As we can see, opposite on the other side of facing QS, 15 degrees, opposite to the side QS, or we may say QS is opposite to the 15 degrees angle. The adjacent side we have right here, and the hypotenuse is the longest side. So we are working in order to find QS, which is the opposite, and the hypotenuse is 12.6. The sine trig ratio is applicable. Substitute, we have QS over 12.6 is equal to sine 15 by transposing QS is equal to 12.6 sine 15, and that in one shot is 3.26 meters. Next, we will find this angle Q right here, that is described to be what? RQS. RQS is in the other right angled triangle, which is this one that we have right over here. So RQS is in the other right angled triangle. Adjacent to that angle, which is RQS, we have 3.26 meters. So if we are talking about the angle at Q, which is the angle RQS, adjacent to that angle we have 3.26 meters. The hypotenuse is the longest side, and opposite to it we have SR. Therefore, what we need to find is RQS. This side is adjacent, that we know, and we also know the hypotenuse. The trig ratio that makes use of adjacent and hypotenuse is cosine, and cosine is equal to adjacent over hypotenuse. 3.26 over 8.4 simplifies to give 0.388. So cos of RQS is 0.388. In order to find RQS, we need to take the inverse of the cosine, which is the cos inverse of 0.388. So RQS is equal to cos inverse of 0.388, and what do we have that to be? RQS is 67.2 degrees. Kind of place it right here in a crowd, but in a few seconds we will have it quite clearly shown. So RQS is 67.2 degrees. There we have it. We need to find the area of the triangle PQR, this large triangle. That may be done as long as we have two of its sides and the angle that they form. We have PQ is equal to 12.6. Here, two sides. We have PQ is 12.6, and we have QR is 8.4. So we have two sides of that triangle. We need to have also the angle that the two sides form. But only a part of the angle that they form is known, which is this part, 67.2. We need to know this one. It can be determined quite easily nonetheless. So there we have the two sides. What do we know? In this right angle triangle, we have the 90 degrees angle, no doubt, and 15 degrees. So the other angle is 90 minus 15, which is 75 degrees. So the entire big angle right there, which is PQR, this angle is the sum of 75 and 62.7, and that gives us 142.2 degrees. The area of any triangle may be found by taking half of the product of any two sides and multiplying by sine of the angle that the two sides form, like this formula, half AB sine C, where A and B are two sides of a triangle and C is the angle that the two sides form. The two sides that form the angle are 12.6 meters and 8.4 meters, and the angle that those two sides form is the sum of these two angles, which turned out to be 142.2 degrees. So half 12.6, 8.4 sine of the angle that those two sides form turns out to be 32.4 meters squared. Some candidates may fall into the trap of attempting to use half base times height in calculating the area. This is especially that QS is perpendicular to PR, and we have its length already. So this, we have QS is perpendicular to PR, so we can use base and the height, and this, the height, is known already, so the students may fall in a trap. In finding PR, we need the lengths PS and SR, both of which are presently unknown. Being mindful of the formula that we used and not afraid to use it have proven to be a savior of time and energy. So if we were about to use half base times height, we will have to find the length of this one and the length of this one, put both of them together, and that will give us the base. But of course we will have to apply trigonometry to both of those, which will be very time consuming, at least a lot more time consuming than realizing that this is 15, this is 90, this has to be 75, and this entire angle is 142.2 degrees. Use the two sides that form an angle and the angle that the two sides form in order to determine the area of any triangle.